Okay, in order to find the voltage, so that you can find or you can determine the current that flowing through the branch or through the resistor, then you have to find the voltage in between the resistor. So we assume that currents entering the resistor, the voltage polarity is always positive. Okay, as for example in here, this is the resistor. Okay, this is the resistor. So when current is entered from the B side, okay, we assume that the polarity when the currents entering the resistor is positive. The voltage for the resistor, which is the Vs is a voltage for the resistor, is equal to the potential voltage at the Vb minus the potential voltage at the Va, which is, we can assume that the Vb, the voltage at the positive sides minus the voltage at the negative sides of the resistor. Same as the figure at the left side, which is this one is a voltage supply. In order to determine the Vs, you can see that the polarity at the left side and then the polarity at the right side. The left side is a positive, which is Va, and the negative side is a Vb. So Vs is a positive minus negative. Then you can get the Va at a positive side minus with the Vb at a negative side. Okay, for the nodal is same like KVL. The summations of currents in one node is equal to 0. So in order to do some equation for the nodal, this is sums of the possibility types of circuit that will exist in the circuit or in a nodal circuit. So this slide will show you on how to find the currents that flowing through the branch or that flowing through the resistor. The most important thing is you have to know the voltage at resistor or the voltage at across the resistor. So this is some example. Okay, for the first figure as shown in here, okay, you can see that the currents is exit the node. In nodal, assume all the currents is exit. So the currents is entering the resistor, and of course the polarity for the voltage for the resistor is look like this one. And then we assume that, so here is the A. In order to determine the currents, you have to know the voltage at the resistor so that you can use the Ohm's law, which is V equal to IR, and then I is equal to V over R. So V here is the V for resistor over the resistor value. Okay, take a look at this figure. In order to find the VR, you must know the voltage at here and also at here. So from here, the voltage at the positive of the resistor is V, And then the voltage at the left of the resistor is A. But we don't know what is the value of A. From the source, we're applying the concept of voltage in the middle is equal to voltage at positive minus with voltage at negative. So from here, the voltage at the positive is A. And then the voltage of the negative here is 0. So 0 is ground. Ground voltage is 0 volt. Okay, from here, in order to know the A, so that we know the voltage at the left sides of the resistor, this one, A at the positive minus 0 at the negative is equal to the middle voltage, which is the Vs. Therefore, A is Vs. So A is Vs, the positive is V. By using the Ohm's law, I is equal to VR over R. So VR is a V at the positive minus V at the negative. So V minus Vs over R. So this is the answer or the equation for the I for this first figure. For the second figure, using a similar concept, but take a look at the polarity of the Vs. You can see that the polarity is a difference with the first figure. Okay, this one is a reverse position. So, do the same step at the first figure. Just assume the polarity here, positive minus, so VR, so positive is a V, the negative is the A side, and here is 0. So 0 minus A is equal to Vs, so A equal to minus Vs, and then I is VR over R, which is for the VR is a V minus A over R. Therefore, V minus Vs over R. So the equation will be V plus Vs over R.